Hey, hello everyone. I am Žydrūnas, CTO at Oxylabs, so nice to be here. And let's get started. All right, so I'm going to speak about ensuring scalability in data collection, so the key components like challenges and advancements. So let's stick to the plan. So a very small agenda today. I'm going to cover the typical web scraping pipeline. I will talk about proxies, how they work, what it is, about headless browsers, and of course advancements, and recapping all that stuff because it will be some stuff there. Alrighty, so what's the typical web scraping pipeline? So we see, as usually, we need some data, right, to input, like what we want to scrape. We have typical then components like proxy management, like fingerprint management. We also have headless browsers or browserless clients, sorry, and that composes the web scraper in essence, right? Afterwards, we have a proxy infrastructure or proxy load balancing, and then we just able to scrape the data and get the raw HTML as a result. Then we can parse it with, as Gabriela mentioned, LLM solutions and whatnots, cleanse it, and then we have the final result. So that's a really, really typical schema in which we trust our web scrapers, right? And today I'm going to cover like a third of that with my presentation. So key challenges. Yeah, so the primary key challenge is the famous triangle. It's like, if we're choosing proxies, like what do we want to choose? Are we going to choose cost, success, or speed? The answer is, it's a dilemma. We have to choose two. Sometimes we choose more, but usually we choose two, which is either cheap, fast, but gives us low success. Either we want to have like high success, fast proxies, but that's expensive. Of course, there might be many more combinations, but those are two usual suspects usually when we're choosing proxies. Of course, though the proxies that we choose depends on the use case. Like, what is the source? Why do we need those proxies? Like, is it heavy? Is it blocking? Is it, I don't know, have JavaScript in it, lots of assets? Like, is it video or what is? So we have to keep that in mind. It's like also not only that, but it's tedious selection process. There's many providers in the market, various proxy types. What to choose? Like where's the information that I can trust? And of course, there's a varying session time, which is very important for choosing any proxy. Like if I know my target, I plan my time, I plan my resources, like how much time I need to collect all this data. Am I able to reuse those proxies as much as possible within a single session or not? So that's really important. And yeah, so tips on proxy management. Use things or solutions that been researched already. So, and we're referring to the Proxyway research, which is being done over a yearly basis, and they evaluate each and every provider. So I think it's a quite good material to work with and start with when you're planning to use your like scraping operations and choose a proxy. Again, you need to know your public data source. So how heavy it is, how it's being protected, how often information changes. So that's very important in proxy management in choosing the right proxies. Plan your workload. It's like, how many requests per second do you need? Like, what's your expectations? Like, how much data points you want to collect? Proxy types, and we'll cover next. What are the possible proxy types? Like, what's there in the market? And proxy amounts is like, do you want to collect data at once, one big batch, or you are like collecting data every Monday for business reporting? And the proxies are matters here. And of course, the other topic I'm going to cover is balancing. And again, as uneasy as it sounds, you have chosen provider, you have chosen proxies, but be ready to change them because you will block them. That's for sure. Okay, slides. Thank you. Proxy type selection. So we have basically two parallels usually. So low-cost proxies, high-cost proxies, and highest chance to be blocked and lowest chance to get blocked. So let's start quickly. So home IPs are the most common thing that we all have. Like we all have internet, right? Maybe. It's easy to get started, experiment, and get blocked, of course, and try various strategies. Next natural step, one would think, is cloud providers. We have AWS, Google, Azure, lots of IP addresses available, lots of resources available. I can lease and can discard. It's like easy, yeah. But we're talking about in the hundreds of IPs. Next to shared DCs, we have also like hundreds or maybe thousands of IPs available. It's a bit more comparably expensive than cloud providers, but it gives you that natural feeling of what could be the DC proxies and what could be experienced with them and scraping, right? Second natural step is dedicated data center proxies, and we are speaking about thousands of proxies, like even hundreds of thousands of proxies that works for us, for our case. It's like we want speed, we want accuracy. Okay, so it's dedicated data center proxies. However, if we found ourselves in a situation when usually most of the hardest targets do nowadays, they simply block DC proxies. So you need different type of DC proxies. It's ISP proxies, which is more expensive, but we again talking about in hundreds or maybe thousands of IPs, which in most cases helps to work around the previous issue. And then we are stepping into more expensive range with residential mobile proxies. For sure, it gives you a high success rate, but it has this nuance. It's mobile device. You cannot trust it in a sense that it always will be online. So it drops constantly sessions, it drops and changes address. It's a nuance, but it gives you a great success. And the pinnacle, the premium quality is actually the residential proxies, the desktop proxies. So highest cost, lowest chance to get blocked. So that's the flavor of proxies. And then we should go to this question, I chosen proxies, like how I should effectively use them without building any scrapers. So it's load balancing, right? The simple schema for your convenience is this. I have, let's say, 3 requests. I can, in parallel, divide those requests for each proxy in 3 proxies, and that's fine. So I have very simple schema. So what are the challenges? The challenges are the basic round-robin balancing. You cannot do any smart balancing solutions there because it's, well, vanilla software, let's say, load balancer. But you can build your own, of course. Why not? Moderately handles requests and IP quantities. Again, it depends on the use case and depends on the provider that you choose. Like how many data you're going to collect, what's the throughputs, what's the requirements for computation. Again, without any significant monitoring or other quality checks, it's really easy to get blocked. And choosing, again, the right provider really matters. And the one interesting note is that success can only be measured from the content that you get, not on the proxy level, because it misses the key component, which I'll talk about a bit later. And so the tips. Basically, make sure that IP lists are easy to swap, because you will block IPs and you need to change them, so you have to have really good means to change. Collect request metrics for IP quality monitoring, so you want to know which proxies are dead. Not the success rate, but which proxies are dead, because you need to replace them or even block them. Play with load balancing algorithms, because there are many, like sticking, non-sticking. And we can use like sticky sessions for one request lifetime to use the single IP to fetch all the resources from the website, right? So that's pretty much efficient. And if you're looking to advanced case, we have many more requests to spread, and we have many more buckets of IPs available. So we want to have a hybrid proxy solution, right? Where we utilize at the same time DCs, ISPs, and RASes and whatnot, and we apply and configure that the fingerprints would match, right? And we have something called exponential backoff, because naturally human beings doesn't browse Amazon on 1,000 requests per second. So we want to be effective and undetectable, right? So the challenge is actually smart balancing and traffic routing. For that, we need something which is called load balancers with a state. We need to have state. We need to know how it works. And of course, here is, for example, if we're using software-defined load balancers, we can use Lua programming language and do what we need. Choosing the right load balancer for feature compatibility is also important. It's like if you're not able to find anything in the market, you can build your own, of course. But I suggest start from software available already. Again, choosing the right provider and hardware is also important because there will be many throughputs. You want high availability, high resilience. So you need to think like maybe balancers of load balancers. Yeah? And building an intelligent browser fingerprinting service today is really kind of getting out of edge, like LLMs, AIs, all of that. So it's very important to know like what is a fingerprint in essence, like how you're going to build, what's the sources, like how it will work. And tracking response time and status codes and proxy cooldowns, like as I mentioned, is really a good challenge. So how to solve those? Implementing source status code aware balancing is a must here. Hence, we have load balancer with the state and usually controlled with Lua, as mentioned in our example. Using the best performing IPs for data collection source, right, based on success rate. So that means whatever we have buckets of different IP types, we want to make sure that we select those IPs which works best. That means trial and error, try and see how it works. Limit how many requests we do and what's the rate, because we want to have a gap between scraping so that proxies will be cooled down, maybe return their quality and all of that. Utilizing browser fingerprints and aligning them via TLS fingerprint. It's the thing which, it's one of the hardest things to do right now. And when we're talking about, setting up Puppeteer and using a simple Chrome user agent no longer works because it's a one fingerprint. When we want more advanced things. And the magic ingredient here is mitten or MAD in the middle. So you have to plan, like if you want to control proxies at the proxy level, at the success rate level, you have to have it. That's no way around. And setting up IP lists based on a hybrid proxy solution, DDCs, ISPs, sometimes doesn't give you a result because more clever antibot system uses geolocation. You can only access content from Singapore, for example, right? Some infamous target. Yeah, and so let's go on to the headless browsers. So the key points is difficult to maintain. They crash, they fail, we need to scale. They use a lot of memory, they use a lot of traffic, they use a lot of network. They are costly, hence they are costly to run. Like those operations are really need more resources, money, people. And based on open source, which is a curse and a blessing at the same time. Why? I'll explain a bit later. And the challenges are like session management, like how do you reuse session between headless farms? So you need some solution there, like even how do you share session, I mean not only cookies, but browser contexts, right? And those are important. The scalability is like how much is enough? Like how many headless browsers do we need to run? Is it hundreds, is it thousands? If it's tens, maybe it's enough, I don't know. Traffic saving is de facto the most important thing because we use headless browsers to render sites, load assets. Caching, there, I've separated it in a separate category because it has its own importance. And of course, headless browsers has a challenge with antibot systems, right? Antibot systems quite easily detect nowadays open source browsers because, well, the open source, that's the curse of open source. And so tips from our side is, well, basically you should stick with somebody with some solutions that you know best. It's like either Playwright or either Puppeteer, well, whichever matches your organization code standards and technologies that you use. Of course, primarily we use headless only for JS rendering or advanced unblocking scenarios. Well, we needed some actions from the browser, right? And effective resource management. The Playwright and the Puppeteer is really good at that. So proxy management, we have covered like hybrid proxy solution. Balancing is the thing that you need to have, like to effectively use headless browsers. OSS patching is open source patching and tracking. This is the blessing of open source. So every day somebody pushes new changes to the GitHub, to the open source, and you need just to follow and find it there, use it, enhance it, and it's your own. And you have to, essentially in-source all of that. If you're doing that, most likely you're quite successful. And web assets management, so in running headless farms, we don't want to have like simple timeouts of 60 seconds waiting until the content is loaded. It's resource hog. So what you want to have is like waiting specifically for that time when the content is finished loading. We want to block as many assets as possible, like images, videos, but we do not want to block JS files, right? Because JS files are responsible for delivering content. And okay, so what happens when JS file waits about 5 megabytes? Is it cost effective? Is it traffic effective? No, it's not. So you have to think about caching, like how to say to the source, I already have this chunky file, I don't need it, so I can effectively run the scraping operations. And so the advancements. So modern headless browsers with a focus on session management and content load optimization is a thing which is currently being on the rise and various solutions appearing. Large language models for data parsing, cleaning, and normalization is like everyone uses, right? So we'll have some updates from Oxylabs as well. The open source patching and community collaboration is like, if you go like, I don't know, like 2 to 5 years ago, there would be like none. You will have to know exactly where to look for. Right now, it's abundant. Like, guys are literally just spilling the beans everywhere. Modern proxy load balancing solutions and advanced IP selection is also a thing, because recently we have at least a few new projects where they claim that you can use like various proxies and itself balances them. So you need to check, you need to validate. And effective antibot solution uses the reinforcement learning and adaptive scraping. And I can say about both sides the same. Antibot systems tries to leverage AI to block, and unblocking teams leverage AI to unblock. And I think what we will see in the future, not the cat and the mouse game anymore, but AI games, like who is the best and who can learn faster from each other. I think that's the future that we're going into. And to recap, selecting and managing proxies effectively is really challenging tasks. So that I think my suggestion here is to use respective research, data, and try it yourself. Spin those proxies, use them, try it. Upkeeping headless browsers at scale is really costly. Not everyone does that. Not everyone has this private Kubernetes cluster or resources hanging somewhere in the basement. So that's a challenge. And sharing sessions between proxies effectively inside headless browsers is really an art. You need an engineering degree there to do that. Traffic optimization is never ending. As mentioned before, websites change their structure, change the assets they load. Even antibot solutions clever today, they can feed you and inject you a video if you're unaware, and there you go. Your traffic optimization is basically non-existent. And avoiding antibot system requires a lot of time and resources. It's never-ending process. If you unblocked one site, most likely after a week you will get blocked again. So it's tedious and never-ending process. And if you don't have time and resources, well, what I suggest to use Oxylabs scraper APIs. After all, it's OxyCon. It's about innovation and about products. So Oxylabs scraper APIs, smart proxy management. Check, it's there. Advanced unblocking strategies, you got it. Custom built and advanced parsers, yeah. We develop our own parsers for dedicated targets, but you have your own parsing instructions available that you can supply to our web unblocker, for example. Headless and browserless scrapers baked in. We use interchangeably them, and to make sure that we will get as bigger success rate as possible. The browser instruction is another thing. Like, if I want specific actions to be done, and you guys do not develop the parser or scraper for us, yeah, there you go. You have browser instructions. It's easy to use. It's like commands like click, follow, insert. There you go. And of course, a high success rate. So our product ensures that you always will get the highest success rate possible, even if it means interchangeably changing browsers, fingerprints, proxies, and all of that. So thank you.
Stay, but stay.
Stay?
Yeah,
okay.
yeah.
Oh, okay.
Come, join me. Join me. It's really important to understand scalable infrastructure for large-scale data collection. So thank you for this talk, Žydrūnai. Ready for some questions?
Shoot.
Cool. I want to remind all of our attendees that you can ask questions on Slido, and we'll get started with a few that we have already. So the first question we have is, how does Oxylabs handle load balancing and task distribution in their scraping infrastructure?
Well, I think every software engineer knows the thing, simple messaging queues, well, and microservices-oriented architecture. So you scale on demand based on how many messages you have. So I think that's the standard.
Okay.
The other one, I think, is that, well, depending on the infrastructure and scale, you might want to scale not only horizontally or vertically, but by z-axis, like having dedicated machines there only for that. It's another way to scale, of course. It's like, if you know if you're scraping like 1,000 requests to one site and another, and like 100 to another, maybe there's dedicated hardware could help there. Like, for that specific purpose, for that specific target, or universal, in a sense.
Okay, thank you for that.
Hopefully I answered.
Another question we have for you is, proxy is becoming a commodity. How do you make a choice when having so many options to opt for?
Well, I would suggest, again, be your own Sherlock Holmes. And you know your target, what it is, how it works. Try proxies, try different providers. Try different proxy types, amounts, requests per second, like see how it behaves. And there's no single answer, use only this or only that. It's your experience. I mean, what are you trying to achieve?
Okay, cool. Thank you for that. Another question we have from our attendees is, what were the key challenges you faced in your team when implementing machine learning and AI processes?
I think the most important aspect was that, with what happens with innovation, it's either too early or too late. So I think maturity is the right answer. And when we started experimenting with AI and parsing, the AIs wasn't that, let's say, mature enough, right? Although with the recent developments, advancement in ChatGPT, for example, or one model, we see quite a really exponential progress and success there. And I think applying those, testing every day, seeing what works is, well, it's essential.
Okay. A couple of more questions, if you don't mind.
Sure.
How would you advise LLM companies to scrape large quantities of multimodal data quickly and successfully?
Well, you have to have scalable proxy infrastructure, of course. Well, and you want to scale your workloads. It's like, again, use the same messaging queues, spread the workload even with different providers. I know that, for example, for AI companies nowadays to scrape, they want to scrape the whole internet, and you have limited amount of time, so you have to be clever about it. But reinforced learning, RAGs or all of that, so requires quite a lot of data. So you have to make sure that you have this infrastructure in place. Maybe having some sort of cleverly around it, like having persistent sessions with proxies, utilizing the best proxies available. I mean, in the sense of lowest response time, highest success rate. It helps a lot. I mean, for those use cases, the essentially response time is the most important.
Okay, thank you very much. And also one last question, we have time for one more. So as mentioned, residential mobile are comparatively less successful than the residential ones. OxyCon website has less cost for residential. Any specific reason?
I would like to see this research where the mobile proxies are less successful, first of all. I think, to my opinion, okay, so my honest opinion is residential proxies are really the best product possible. But many users are mistakenly thinking that only choosing residentials will solve their problems. It's not. You have to have clear strategy how you use them, right? And mobile proxies itself, it says like you have like a device which gives you an internet. It's a mobile device. It's real. It's a fingerprint device, right? Essentially. So, but it doesn't have that durability, right? Maybe that's the reason why people think that with mobile proxies, although it's kind of comparatively the same price as residential, so it will have lower success rate. It depends how you implement your scrapers. Are you repeating requests? Are you continuing? Are you monitoring? All of that.